Hello, this video is for my pre-calculus students, all three of you. I'm doing lesson 33 in the book, the derivative of x to the n. This is what you'll be pleased to hear is the lesson I call the shortcut. We've already dealt with how to find the derivative of a number by using the formula for the derivative, the function of x plus change in x minus the function of x all over change in x, and we've done all that work showing all that multiplication and distributive property and whatever else it takes to solve for this, and it's good stuff. But if you do enough of them, you do find a pattern, as we often do in mathematics, and from that pattern we can derive and find a shortcut so that we don't have to jump through all the hoops that we do to find the derivative that we've done so far. I had asked you in class a couple of times if anybody could see the pattern, and I think you were starting to get it, but this lesson will just make it very clear and we'll point it out. Here's some examples of numbers that we're taking the derivative of. I'm on, by the way, on page 175 of your book. I'm not going to go over the graphs and all the explanation of working out the problem as they do on this page. In the middle of the page, they ask to find the derivative of x cubed. The notation is d over dx of x cubed. And at the bottom of the page, they come up with the derivative is 3x squared. Here are some others that I've just put up here. These are not in your book, but I just put them up here to help show the pattern that we're looking for. If we're going to find the derivative of 5x squared, it becomes 10x, or more correctly, 10x to the 1 power. If I'm finding the derivative of 8x, it just becomes 8. The derivative of 4 is 0. And then we get into some confusing stuff. The derivative of 1 over x is negative x to the negative 2 power. Let me show you what's happening here. This is the shortcut right here. Anytime you're taking the derivative of a number, and it has a power, it's real simple. This power just jumps to the front of the x, or whatever variable is there, and becomes the coefficient. And then the power is subtracted by 1. So in this case, when we have technically 1x cubed, and we take the derivative, that 3 goes to the front and gets multiplied by the 1. It becomes 3. Then we do 3 minus 1 to get the squared. Now, in later lessons, we'll get more involved. These are all just one terms, just a single term, and relatively simple. But it gets more involved, but here it is to begin with. We look at the second one. We've got 5x squared. That 2 jumps to the front, and it doesn't become 2x. It becomes 2 times the coefficient that's already there. 2 times 5 is 10. Then to find the power, I subtract 1 from 2, and I get to the 1 power. So again, 2 times 5 is 10. 2 minus 1 is 1. The derivative of 5x squared is 10x. 10x to the 1 power. When I look at the 8x, that's technically 8x to the 1 power. 1 jumps to the front, gets multiplied by 8. 1 times 8 is 8. 1 minus 1 is 0. Technically, that's 8x to the 0 power. We know that any number to the 0 power is 1. So this is technically 8 times 1, which we just call 8. We don't need that x to the 0. This 4, the derivative of 4, well, we have not written it up there. There's technically an x to the 0 power right there. The power of the 0, the power of the x, 0, gets multiplied by 4. 0 times 4 is 0, and 0x to the negative 1 power, which just becomes 0. 0 minus 1. Here. Here's the derivative of 1 over x. It's negative x to the negative 2 power. I'm going to need to explain that a little more. That 1 over x is technically x to the negative 1 power, right there. So when I find the derivative becomes negative 1 to the front, still x, and then I subtract 1 from the power. I've already got a power of negative 1. I subtract 1 from it, and I get to the negative 2. So I get negative 1 times x to the negative 2 power, which could be written as negative 1 over x squared. Either one is acceptable. Okay? If we had had 1 over x squared, that would become x to the negative 2 power. That's it rewritten. The derivative becomes negative 2. That's our coefficient. Jumps to the front. And x, what's negative 2 minus 1? To the negative 3 and on down the line. So that's it in a nutshell. That's the shortcut. Relatively easy. Excuse me, I dropped my rag here. So we're going to go over all of the examples. I don't think I said this at the beginning. I meant to. This video might be a little longer because we've got several things we need to cover here. And we just want to make sure we get it covered well. I'm going, so on page 176, they jump through all the hoops to find the derivative of x to the n power. Okay, that could be any number. And they come up with this formula. Let's just show it. That n will jump to the front, become the coefficient, and then we take this number minus 1. So there's your formula for the derivative of any term. Okay? If this is confusing, which I know formulas often are, just remember, as we did in these practical applications, take that power, jump to the front, multiply it by whatever's there. Oh, sorry, I'm doing the wrong one. 3 jumps to the front. Oh, and guess what? We could easily do this. What's the derivative of 3x squared? Well, the 2 jumps to the front. 2 times 3 gives me 6. X, what's 2 minus 1? 1. We could go find the derivative of that if we wanted to. In fact, in later lessons, we'll be finding first, second, and third derivatives of numbers. It's actually not that hard. Okay, I'll leave this up here. I'm going to go to page 177, and they give several examples of how to find the derivative. Before they do that, though, at the top of the page, they give different notations for finding a derivative. They show several that we've already gone over in class, and then they come up with new ones, which are much easier and I really like. They have d over dx times y, dy over dx. We're familiar with that one, dy over dx. That's the same as change in y over change in x, which we know is slope, which is what I said from the very beginning. A derivative is just a fancy name for a slope, okay? And other notations. Y prime, f prime, and f prime of x are going to be the three new notations they give us, meaning find the derivative of, okay? So in this first example at the top of page 177, 33.2 says find y prime if. Find the derivative of these things. In A, it says y equals x to the 4. Well, the derivative of x to the 4 jumps to the front. 4 minus 1, 3. You're done. We didn't have to go f of x plus change in x minus f of x all over change in x. We could. You could go do all that tedious work if you wanted to, or you can do a shortcut. That's what math is about, finding patterns to make things easier. Okay? There's the first one. Still in that example, it has y equals x to the pi power. What on earth? To the pi power? I've never had to deal with that. Doesn't matter. That pi, to find the derivative, that pi jumps to the front. There's your x. Well, and what is the power? Well, it's just pi minus 1. That's all you have to write out. You don't have to write 3.14159 and then do 3.14159 minus 1. Well, that's 2.141. Nope. Just leave it as pi minus 1. You're good. Okay? Next example says the function of x is x to the negative 7. Find the derivative. Well, it's not hard. Negative 7 jumps to the front. And then I do negative 7 minus 1. Negative 7x to the negative 8. Next one says 1 over x to the 15 power. When you have a fraction like that, the coefficient is, well, I'm not going to get into that. We're going to change this to x to the negative 15 power. Your derivative will become negative 15x. What's negative 15 minus 1? Negative 16. Once you learn the pattern, as I've said, I'm repeating myself, it gets relatively simple. The next one says x to the negative 2/5 power. Well, the negative 2/5 jumps to the front. What's negative 2/5 minus 1? Well, that's negative 2/5 minus 5/5. We're going to have to the negative 7/5 power. I'm at the bottom of the page. It says if s of t, you're not saying f of x, you're saying s of t, same idea. And they say t to the 3/5 power. Notice whatever this t is taking the place of x. So this is going to have to be t to a certain power. And then they say find s prime of t. Well, that's just, they've just put this prime, this dash on it, and that just means find the derivative. Then it says and ds over dt. These two are saying the exact same thing. There's no difference in them whatsoever. It says, in fact, in the explanation, the solution, it says these are all notations for the derivative. Oh, I'm sorry, there was even a third one. It said find s prime also. Those all say the exact same thing. So we just take 3/5, bring it to the front, t, and now I do 3/5 minus 1, 3/5 minus 5/5. That gives me to the negative 2/5 power. No real mystery to that. I think there's a couple more examples. Something I need to point out from the lesson. On page 178, numbers 3 and 5 are very different. They say, and I'm not going to write up like f of x equals. I'm just going to put up the number we're taking the derivative. The cube root of x. Well, how do we write that as x to a power? Well, that's simply x to the 1/3 power. Once you've changed it, I've had students in the past say, "Oh, I'm done." No, you've changed the form, but you still haven't taken the derivative of it. Make sure you take the derivative of it. 1/3 x. What's 1/3 minus 1? Well, that's 1/3 minus 3/3. 1/3 x to the negative 2/3. The next one says the 4th root of x cubed. Well, what does that mean? Rewritten, That's x cubed all to the 1/4 power. I'm going to come down now. That's x to the 3/4 power. What's the derivative of x to the 3/4? I don't know. 3/4 jumps to the front. And now it's 3/4 minus 1. 3/4 minus 4/4. Negative 1/4. That's the shortcut. Lots of examples that show how to do it. I'd like to assign you this lesson, lesson 33. If you have questions, email me, as a couple of you have already done. Hope that clears up some things. We'll have more later in the week. Thanks.